Okay, in the last lesson we talked about translation, and of course translation is the way that we slide objects in certain directions in certain units as a way to show transformation. Today's lesson is going to deal with the reflections. Now reflection is something you've probably already seen somewhere in elementary school, or at least have talked about reflection. Basically, it is what you think it is. It's like as if you stood at a mirror and you put your arm's length away from the mirror and you put your arm up to the mirror. Your reflection would be, or at least appear to be, the same distance away as you were standing from the mirror. So we're going to look at several different examples today dealing with reflection. Talk about a couple things like line of symmetry and line of reflection. But first, let's start off with a paragraph here on this page. It says, a reflection can be seen in water, in a mirror, or in a shiny surface. An object and its reflection have the same shape and size, but the figures face in opposite directions. In a mirror, for example, right and left are reversed. A reflection occurs when you flip a figure over a given line, and this mirror image in that line is created. So take a look at this picture. So here we have shape A, B, C, and D. This line here represents the line of reflection. One thing I want you to notice that B is about the same distance, or is the same distance from the line of reflection as B prime is. You could say the same thing for all of these letters. D is the same distance to the line of reflection as D prime is. Same thing with C and C prime, and then finally A and A prime are all the same distance away from your line of reflection. Okay, so that's important to note as we go forward, as we look at several different examples, especially when it comes to the coordinate plane, which we'll look at in a moment. But the next thing I want to talk about is line of symmetry. So let's take a look at the next page. So line of symmetry is where you can cut a shape in half where you have the left side being the same as the right side. So, for example, if you look at this first shape here, I notice if I cut this shape down the middle, vertically, try that again, the left side does in fact equal the right side. And a shape like this actually has more than one line of symmetry. So if I keep drawing here, I notice it also has a line of symmetry horizontally. And in this case, we can actually cut it diagonally as well. So go ahead and do that. So this shape actually has 1, 2, 3, 4 lines of symmetry. Okay? So take a look at the star-looking shape over here and see if you can figure out, well, where are there lines of symmetry? So go ahead and hit pause and see if you can find some lines of symmetry. Okay, so just like the previous example, this does have more than one line of symmetry. And generally, you're going to start at the tops of the triangles and draw a line diagonally down through the shape. And you notice that this right side is the same as this left side, but the shape does have more. Okay. And this shape here has 3 lines of symmetry. It does not have vertical or horizontal. I can't, actually I can, sorry. There's more. My bad. So we can keep cutting that bad boy through there, through all of those triangles. Okay, so there is an example of all the lines of symmetry in that shape. Now, take a look at the next shape down here. Now, this shape, I'll give you a couple seconds to take a look at and see if you can find any lines of symmetry. Well, in this case, there is no line of symmetry. I cannot create a line where I have reflection where the left side equals the right side. It does not happen. This black doesn't match up with this white. I can't do it horizontally. They don't match up. So this does not have any lines of symmetry. So the shape would not be considered symmetrical there in that case. Now, go ahead and try the next one to the right. See how many lines of symmetry you see there. Okay, so I have a vertically, I have horizontally, I have diagonally, and diagonally again. So this one has 4 lines of symmetry. Now, a common type of situation you have are alphabetic letters. Now, some alphabetical letters are symmetrical. So go ahead and see if you can identify which letters down below have symmetry. Go ahead and draw the lines of symmetry as well. So go ahead and do that and hit pause. Okay, so let's take a look at A. A does have line of symmetry. Capital A just has vertical line of symmetry. Take a look at B. B does have a line of symmetry. It is a horizontal line of symmetry. F. F does not have any lines of symmetry. I can't cut that in half where one side matches the other. How about J? Well, if I cut it in half here, I notice I've got this down here and it's not on the right side, so therefore this does not have line of symmetry. And our last letter, M, M does have one line of symmetry there. Okay, so let's take a look at the next situation. So now what we're going to be taking a look at is lines of symmetry or lines of reflection on a coordinate graph. So when you take a look at these two shapes here, I've got A, B, and C, and triangle A prime, B prime, and C prime. And one of the things you should realize is A prime, B prime, C prime is a reflection of A, B, and C. Now, where is that line of reflection? Well, in this case, it happens to be the x-axis. And again, please note that C is the same distance away from that line of reflection as C prime. A is the same distance away from the line of reflection as A prime. And B is the same distance away from that line of reflection as B prime. Okay, so that's one of the ways you can tell where the line of reflection is. Now, one of the things I want you to recognize or start to think about as we move forward is, excuse me, how are the ordered pairs affected when we reflect across a line of reflection? Okay, so we'll get into that in a couple minutes. All right, but let's take a look at some examples. So on the next page, I have some shapes, and what we're going to do is we're going to reflect these shapes across the lines of reflection. And in the first one, we are going to reflect across the x-axis. So at this time, take your straight edge, and if you want to, draw a straight line on the x-axis, just like I did. So now we're going to go ahead and we're going to draw this shape reflecting across. Now, again, what a lot of people would do is they would simply draw the following. But you have to realize that when you reflect something, it's going to flip a little bit. It's going to get a little bit of the reverse picture. So let's take a look at this. So let's take a look at this point right here. Oops, right here. And again, the distance has to be the same. So I notice it's one space away from the line of reflection. Well, its new point, I'm going to put one space on the other side of the reflection. Let's take a look at the bottom left corner of this triangle. How far away from the line of reflection is it? It's 1, 2, 3, 4. So I'm going to put it 1, 2, 3, 4 up. So my new line of reflection goes right there. Take a look at the bottom right. And again, it's 1, 2, 3, 4. So that means I'm going to go up 1, 2, 3, 4. And put that blue dot there. Now I have my shape. So notice that the shape did flip across the line of reflection. Okay. So now let's take a look at the one on the right. Again, we're going to reflect this across the x-axis. So go ahead, draw your straight edge. Use your straight edge to draw a line across the x-axis. Go ahead and see if you can do this one on your own. Hit pause. Check your answers in a moment. Okay, hopefully your answers look something like mine. Again, take a look at the distance. You can see these distances are the same. How about this vertex of the triangle here? I've got 3 spaces to the line of reflection. And again, I've got 3 spaces to the line of reflection. Okay. Take a look at the next situation. Now we're going to reflect across the y-axis. So take your straight edge. Draw a line going down your y-axis. And let's again take all 4 points of this quadrilateral. So the first point is 2 spots away. So I'm going to be 2 spots away on this side. 1, 2. Put a little point. The next spot is 1, 2, 3. It's going to be 3 spots away there. So I'll put a little dot. And you can kind of see here it's a little bit easier to figure out what this shape is going to look like. It's a nice little rectangle. And it's going to reflect across the y-axis. Okay, so try the next one on your own. First thing you want to do is draw your line of reflection because we are reflecting across the y-axis. So go ahead and hit pause. Try this one. See if your answer matches mine. Okay, so hopefully your shape looks very similar to mine. And again, we want to be here 3 spaces. So I'm going to be 3 spaces across. Here, this corner is only 1 spot, so 1 spot across. 3 spots, so 3 spots across. Okay. If you're having trouble doing this or your shapes aren't looking like mine, feel free to raise your hand and ask for help. Okay, now the last two we're going to talk about aren't as common as the ones we just did, but they do occur, so it's important to talk about them. The first one is a reflection across when y equals x. Well, when y equals x, you get a line that looks like the following. Let me draw this, and then you go ahead with your straight edge, and you can draw it as well. So when you take a diagonal, when 1 equals 1, or when x is 2, y is 2, when x is 3, y is 3, when x is 4, y is 4, when y equals x. That's what that line looks like. Now, this one's a little bit more difficult to draw the reflection, and you'll see how I do this starting now. So let's take a look at the first corner here. So again, how far away is this corner from the line of reflection? Well, if you look, it's one diagonal box. So what am I going to do to find its reflection? Well, I'm going to go across one diagonal box, put a dot. Okay? Put a dot there. Okay, so take a look at the next one. Let's take a look at this guy up here. Now again, go diagonally. It's because you want to be perpendicular to the line of reflection. So 1, 2. There's 2 diagonals from the line of reflection. So I'm going to go 1, 2. 2 diagonals from the line of reflection. Put a dot there. Okay, let's take a look at the bottom left-hand corner here. Again, diagonally. Now this one's a little weird. It's 1 full box, 1 half box. So I'm now going to go 1 half box, 1 full box. Put a dot there. And then the last corner is, we'll say up here. So we're going to go diagonally 1, 2, 3. So that means I'm going to go, I'm sorry, that was 1, 2, 2.5. So I'm going to go a half, 1, 2. That lands me right here. So I now have my shape across y equals x. Again, this one's a little bit more complicated. Don't necessarily panic right now if you're a little bit confused at this point. It's more important that you understand the top two, but it's important that we take a look at this. So y equals negative x. That is in the opposite direction. So for example, if x is negative 1, that means y is 1. So this is what that line looks like. That's an awful line. Let's try it again. I'm having difficulty drawing lines. Okay, there we go. So you do the same thing. How far away from the line is each point? So I'm going to start here. And this is 1.5. So half 1. Here's where the first dot goes. Do the next one. That's 1, 2, 2.5. So I'm going to go a half, 1, 2. That's where the next dot goes. And then the last one, 1, 2.5. So a half, 1, 2. And that's where that dot goes. Then go ahead and draw your shape. So you can see there is the reflection across y equals negative x. Again, a little bit more difficult. Let's focus on the other ones as well, but it's important at least you recognize something like this. Okay, now take a look at the next page. So now, sometimes we don't necessarily go across the y-axis or the x-axis. Sometimes we'll just go across a point along the y-axis or x-axis. So let's take a look at number 1 here. It says, reflect across when x equals 2. Well, where is x equals 2? It is right here. So that means I'm going to take my straight edge and draw a line